In this video we are going to look at an exam style question that requires simultaneous quadratic and linear equations. Well, let's look at the question. We have a linear equation y equals x minus 3 and a quadratic equation y squared plus 5x equals 10. Well, the question says, show that x squared minus x minus 1 equals 0. When you have questions where it says show that, you have to start with the information given. So the information given is represented by these two equations. So the first one is equation 1 and the second one is equation 2. Well, I want you to notice that this final equation that has to be proven has only one variable, which is x. For this reason, we have to look for a way where we eliminate the variable y. Well, how are we going to eliminate the variable y? We notice that we can substitute y equals x minus 3 into equation 2. Let's see what happens. So I'm going to use x minus 3 and replace y with it. So x minus 3 all squared plus 5x equals 10. The next thing that I notice is that on the right hand side of this equation there is a 0. So let's move the 10 from the right hand side of the equation to the left hand side of the equation. So we end up with x minus 3 all squared plus 5x take away 10 equals 0. Just remember, when you move one term from one side of the equation to the other side, you have to change the sign. So this is why 10 becomes negative 10 on the other side. I want to stop here for a minute because there is this perfect square that we have here, x minus 3 all to the power of 2. And when students expand that one, many students actually forget the fact that we have this term in the middle. So they write the first term, they write the second term, but they omit the term in the middle. Well, let's see where that term in the middle comes from. So I'm going to expand x minus 3 all squared. First of all, I'm going to expand it using this formula. So it says the first term squared, which is x, so x squared. Because there is a minus here, we have a minus there, so negative 2 times a times b, so times the first term times the second term. So times x times 3 plus b squared, which is 3 squared. If we simplify this, we end up with x squared minus 6x plus 9. Let's do this in a different way. So we have x minus 3 squared, all squared, can be also written as x minus 3 times x minus 3. If we use the distributive law here, we have x times x equals x squared, x times negative 3 equals negative 3x, negative 3 times x is negative 3x again, and negative 3 times negative 3 is positive 9. If we collect like terms, we end up with x squared minus 6x plus 9. So you do notice here the term in the middle. So never forget this one. This is where it's coming from. So whether you use the distributive law or you use this formula for expanding a perfect square, the answer should be exactly the same. So do not make this mistake that quite many students make. All right, let's go back to our equation. And now what we are going to do, we are going to substitute x squared minus 6x plus 9 in here. So x squared minus 6x plus 9 plus 5x minus 10 equals 0. Now what I'm going to do, I'm going to collect like terms. So we have x squared, negative 6x plus 5x is negative x. And then we have positive 9, take 10, which is negative 1, which is 0. Now you can see that we have actually arrived to this equation that we were asked to do, to show, to prove. So at the end we are going to say as required, or you can use QED, which is the Latin form for what we had to prove, what it had to be proven has been proven. Now, the second part of this question is a show that question as well, but this time what we have to show that x squared minus x minus 1 equals 0 has two real distinct solutions. So we have to show that. Now let's go back to quadratic equations, because this is a quadratic equation, and recall the fact that the discriminant of this equation is going to tell us whether the equation has real distinct solutions or just one solution or no real solutions. So let's recall the fact that when delta equals 0, we have two identical solutions. Some people say that there is only one solution because they are identical, but they are real solution, and they are the same. If delta is less than 0, then there are no real solutions. And the reason for this is because delta is under the square root, so we can't have a square root of a negative number. So what we have to show for two real distinct solutions is that delta is greater than 0. So in this case, there are two real distinct solutions. Well, so let's calculate delta, the discriminant for this equation. What we are going to need, we need a, b, and c. And just recall that a is the coefficient of x squared, which is 1. B is the coefficient of x, which is negative 1. And c is the constant term, which is also negative 1 here. If we calculate delta, we have b squared, which is negative 1 squared, and negative 1 has to be in brackets because both the sign and the value are squared. Take away 4 times a, which is 1, times c, which is negative 1. Just to be on the safe side, I always put the negative values in brackets. So negative 1 squared equals 1. Here I have negative 4 times 1, which is negative 4, times negative 1 gives us positive 4. So 1 plus 4 equals 5. Now 5 is a positive value, so it's greater than 0. So we've actually shown that the discriminant of this equation is greater than 0, which we can conclude that x squared minus x minus 1 equals 0 has two real distinct solutions. Now, in an exam, do not just leave your answer like that, because you have to state your conclusion. So you do have to state that this equation has two real distinct solutions. So this would be your final answer. Part C of this question starts with hence or otherwise determine the value of x. Give your answer in the form p plus or minus q square root of r, where p, q, and r are real non-zero constants. Well, the word hence here has the meaning that you can use what you have found in previous parts of the question. So what we found in part B is that delta equals 5. Now, why is this useful here? Well, let's look at the quadratic equation, the quadratic formula, which says x equals minus b plus or minus square root of b squared minus 4ac over 2a. Or we can write it as minus b plus or minus square root of, remember that this is actually the discriminant, so that's delta over 2a. So because of this hence, you can actually use delta equals 5 in here rather than calculate it again. So x equals, recall that b is negative 1. Don't forget the negative in front of b as well. Plus or minus square root of 5 over 2 times a, which, remember, it was 1. So this gives us 1 plus or minus square root of 5 over 2. When you get to the final answer, if you think this is the final answer, so these are the solutions, the value of x, just have a look at the question again and see if this is the form that you have to write it in. Now here it says p plus or minus q square root of r. So we have to separate it into two separate fractions. So we have a half plus or minus a half square root of 5, because this is the form that is required.